Assalamualaikum warahmatullahi wabarakatuh. My name is Nisa Sharo. Today, my group will present the group assignment of MAT565. So, I will present with two others group members, which is Muhammad Rasdan bin Azli and Muhammad Ahmad bin Zakaria. So, the introduction of Fourier series. Fourier series is a sum of sine and cosine wave that represent a periodic function. Function Fourier transform. FT is an integral transform that converts the function into a form that designs a frequency present the original function. So there are three types of Fourier series. First is full range, the second is half range, and the third one is harmonic analysis. So for the first one, we have to find any function of the Fourier series which is even, odd, and neither. For the first one, the function is given fx equal to 4 minus x power of 2, and the interval given is negative 2 to 2. So after we know the period, we have to find the L, and with the L we know how to plot the graph. After we know the graph, the sketch of the graph, we know the function is given. After we know the function is given, we have to substitute in the formula, which is fs equal to an over 2, and we cos n pi x of L. After we know the value of L, we have to substitute in the formula, which is 1 over L, and integrate negative L to L, function of dx. So half of 1 over 2, because we get the L equal to 2. So negative 2 to 2, 4 minus x squared dx. After that, we have to integrate like usual, and we get the answer 16 over 3. After we get the answer, we have to substitute in other formula, which is an equal to 1 over L, integrate of negative L to L, fx cos n by x over L dx. After we substitute the value in the formula, we have to differentiate and integrate the function. We get that answer. After that, we have to solve it like usual, and we have the final answer, negative 16 over n pi power of 2 cos pi n pi cos n pi x over 2. For the odd function, the function given is x cubed, and the interval was given in 1 to 1. After we know after we plot the graph, we get the shape, and we have to substitute the formula that given. So after we get the value, we have to substitute in the formula 2 over L, integrate of 0 to L function of sine and pi x over L dx. So after we substitute, we have to differentiate and integrate the value that we substitute. After we differentiate and integrate, we have to just integrate like the usual we integrate. So after we integrate, so that the final answer that I get, that for the neither function, we have two equations, which is 0 to 1 and 1 to 2. After that, we have the L equal to 1, and we plot the graph, and this is the shape of the function graph for neither. So after we know the value of L, we have to substitute in the formula. For formula neither formula, we have 1 over L 0 to 2 function of dx. So 0 to 1, 2x plus 1 function of dx plus 1 to 2, 3 dx. And we have to integrate like usual, and we have the answer is 5. After that, we have to insert the cosine formula, which is an cos n pi x of L plus bn sin n pi x of L. So we substitute that into the formula, and we get the answer negative 2 over n over 5. So the final answer is like the stated. That's all. Thank you. So I will pass to my next groupmate, which is he gonna explain about the cosine series and the sine series.
So task 2 is to estimate any function, specifically using cosine and sine series. So the function is x squared, while the range of x is 0 to L. So for cosine series, we can conclude that it is an even function. So the periodic extension for the even function is 2L, and P is equal to L. So to expand by using cosine series, we need to find a0 and an. By using tabular method, we can get an, and then after we get a0 and an, we can define the Fourier series. So for the sine series, we use the same function and the same range for x. For the graph, sine series, we can conclude that it is an odd function. So the periodic extension for it is 2L, same as the cosine series. P is also the same, is also L. But if we need to expand using sine series, we need to find the Bn only. So then we can conclude the Fourier series. So lastly is a Fourier series. Also, we use the same function and same range for x. The graph is neither odd or even function. This is a repetitive function. So with repetitive, we can expand using a Fourier series. So the periodic extension is different from the other tools. It is L, while P is L over 2. So we can see that the Fourier series expansion is much longer than the other tools. We need to find A naught, oh sorry, A naught first, then AN, and then also BN. So we need to find those three, A naught, AN, and BN, to define the Fourier series.
So for the task 3, it is about harmonic series. The question asks, find the Fourier series expansion up to the third harmonic. All calculations must be correct to 3 decimal places. So about the table below is that I choose S and also Fs value. So the table shown is what I construct from S and Y value. So there is a summation of y cos s, y sin s, y cos 2s, y sin 2s, y cos 3s, and also y sin 3s. So look at below the table. There is indicator for A naught, A1, B1, A2, B2, A3, and B3. In order to find C naught, C1, C2, and C3, first we need to find A naught, A1, A2, A3, B1, B2, B3. So after we got all of those values, we can proceed to find alpha for the angle. So alpha 1, alpha 2, and alpha 3. So after we obtain the alpha 1, alpha 2, and alpha 3, also C1, C2, C3 values, we can find and we can build Fourier series expansion equation. So for this question, Fourier series expansion equation conclusion is Fs equals to 1.346 plus 0.481 sine s plus 185.01 plus 0.384 sine 2s plus 991.11 plus 0.183 sine 3s plus 297.69.